How Moon is created? The Moon was formed in a dramatic collision during the early days of our solar system. Around 4.5 billion years ago, when the solar system was still taking shape, something big happened. An object possibly as large as Mars slammed into the young Earth. This colossal impact flung a tremendous amount of molten and vaporized debris into space. Over time, gravity pulled these debris together, forming what we know as the Moon. Scientists named the hypothetical impactor Theia, after the mythological Greek Titan who was the mother of Selene, the goddess of the moon. The moon was initially a fiery molten world covered by a deep ocean of magma for millions of years. The evidence from Apollo missions in the late 1960s and early 1970s confirmed this theory. Lunar rocks and samples revealed the moon's origin from a massive impact. How do we know? The key is meteorites. Meteorites brings many different types of material from all over the solar system to Earth, where scientists can study them. These materials include chondrules, tiny pieces of dust and rocks that have survived from before the planets formed, and pieces of asteroids. Radioactive elements like uranium and hafnium are trapped inside the minerals that make up these objects when they form. But the final stage of planet formation in our solar system may have taken much longer, up to 100 million years or so. This was not only the last major addition of material to the Earth, but also the event that formed the moon, and it's one of the most debated parts of the story. There is another theory about moon. The moon formed elsewhere in the solar system and was captured by Earth's gravity. Sample of rocks from the moon brought to the Earth by lunar meteorites and Apollo moon landings can be used to understand the history of the moon and its relationship to the Earth through the chemistry of the minerals. The first big clue about where the moon came from comes from oxygen. Oxygen, like many other elements, is able to exist in multiple forms known as isotopes. Some scientists believe that oxygen isotopes are because the object that hit Earth was made up of the same mixture of meteorites as the Earth itself, potentially suggesting that the impactor planet formed close by in the solar system. Scientists believe that moon formed during a giant impact about 175 million years after the solar system was born. To arrive at this estimate, they can use rocks from the Earth. Today, all of the hafnium is gone because it has a short half-life compared to the age of Earth. However, not all is lost. This makes it very useful for working out the timing of events in the first 100 million years of the solar system's history.